Howdy, Ivy. It's Miss Kosh. I was asked a question about this problem today, but I didn't have time to think about it because of our practice paper 3. So I wanted to look at it a little bit and then talk you through it. So I don't know how much of this will be relevant. I don't remember where I got this problem. I like parts A and B for sure. I started problem and want to talk through it, and then I'm going to finish. Like, I didn't quite get to the end of this, but I want to do that with you in the video. So the first thing that they're pointing out to you is to figure out what happens with f of x. So what I did is I took this over. Well, that doesn't help. Do I have this? Oh, I just discovered something. Okay. So look, there's a laser pointer. Who knew? Let's do it. Yeah, red's great. Okay. So what I have, I wrote this f of x in green. So I went back to that original problem and said, what is f of x? Well, it's x over 2 minus x. So I wrote out x over 2 minus x, but I plugged in f of x in each of those. So hopefully that makes sense. I decided I didn't want to deal with fractions in my fraction, so I multiplied, and they both had the same denominator, so I just multiplied everybody by 2 minus x over 2 minus x. When I did, that canceled these right here, and it canceled this with this, but then I have this 2 that gets multiplied through by that. Giving me x over 4 minus 2x is what happens when you do the 2 times this, and then this denominator cancels with that, giving me minus x, and I cleaned it up to this x over 4 minus x. And the nice thing is, well, so then they say, okay, here's this whole thing. That if I do f of f of f of f of f of f of f, whatever, of x, and I have n of them, then it's going to follow this rule, which would be x over 2 to the n minus 1 times x. Okay, so let's look at this previous one just a second. If you notice on this, let me use pink. This would be like, this right here would be f2 of x, because we've done f of x, and so we had 2 of those f's. Or we could say this is f of x. I don't know why I wrote the parentheses in that order, but there you go. And that would be equal to f2 of x. Okay, so then let's see if that matches this formula. Well, my formula said this is x over 2 to the 2 minus 2 to the 2 minus 1 times x, which, sure enough, this would equal x over 4 minus x, and that's exactly what I had right here. Okay, so this is good. And actually, to be honest with you, what I just did is step 1 in our proof by induction. So then we're trying to prove that having n like f of whatever, n number of times equals this formula. So step 1, we have to show it for 1. Step 2, we're going to assume that if I have this k times, so f sub k of x would be this, where I came back to here and my n's became k's. Okay? And then I started with f of step 3, so now I have k plus 1 of these f's. Okay? Which means, if you think about it, this is, this is f of the previous k of them. Okay, so because that would be like, well, just off to the side, if I have f of this is silly, x, however many I had, if this right in here, I don't know that I have all the right number of parentheses, and that looks ridiculous. If we could give this whole thing a name, and I wanted to do f of one more, then basically I just have f of the previous thing I was looking at. Okay, I hope that made sense. Let me know if I need to clarify that at all, but I don't quite know how to say it differently at this present moment. Okay, so what I did is I just said, okay, well, what was my f? Well, I came back up here, looked again to see that f is x over 2 minus x. So I have x over 2 minus x, but now what I'm going to plug in for x is what I had just assumed in part 2. So now what I want to do is I'm going to do what I did a second ago and just multiply by that denominator. Sorry, I'm too close to the edge, and so it makes my handwriting bad. And you have to listen to me complain and deal with the messy handwriting. Okay, so that was fun. So then what I have now is I've got the denominators here canceled with that. So my numerator is just x. And I have 2 right here times all of this. And then I have these will cancel. Okay, so that first part is 2 times 2k minus 1 times x minus, so this, you'll notice, this part right here is from 2 times all of this, right? I didn't actually distribute. Okay, now this cancels with this whole thing, and so I just have a minus x right here. Okay, so now let's look at what we're doing here. We have x on the top, and we have a 2k plus 1, because this 2 times this 2 to the k gave us a k plus 1. And then I have minus, well, 2 times 2k minus 1x minus x. Okay, well, so what in the world are we talking about? This, we still have this. And to be honest with you, if you go back, we didn't write down a goal. But my goal would have been for this right here to become, oh, that's big, to become a k plus 1. And we have a 2 to the k plus 1 right here. So that's already encouraging. Okay, continuing on, we have, let's factor out the x. Well, let's do this. So if, notice I can factor out a minus x from both of these two terms. And when I do, I get 2 to the 2k minus 1 plus 1, because I've factored out the negative, so all of this is now here, just as I see it. This becomes a positive 1 right here. Okay, I think we're getting there, and hopefully you can see it. This becomes a 2 to the k plus 1, and then a minus 2, and then a plus 1. That's still all underneath that same denominator. And this is equal to x over 2 to the k plus 1 minus 2 to the k plus 1, and then this becomes a minus 1 times x, and now we've written it in the form that they had given it to us back, well, I wrote it here. Okay, so that's, we should have x over 2 to the k plus 1 minus 2 to the k plus 1 minus 1 times x, and I think that's exactly what we have. Okay, so therefore we can conclude, I should probably rewrite this step, but I don't want to. So this would be my last statement. I would rewrite that. Therefore, this statement right here. Okay, let me see about, I'm not sure that the rest of this is relevant for us at this present moment, and for the sake of this video, I'm going to stop. Y'all can go try those if you'd like, but I do feel good about A and B. So go practice. Good luck.